The Kepler Telescope was designed to specifically survey a small region of the Milky Way for signs of extrasolar planets. The Exoplanet Explorer spent its lifetime monitoring tens of thousands of stars and finding thousands of exoplanets. Launched in 2009 atop a Delta II rocket as part of NASA's Discovery program, Kepler's mission was to continuously scan a predetermined region of the Milky Way for planetary systems. When it was launched, its primary mirror was the largest one of its kind. Moreover, it was equipped with a 96-megapixel camera for capturing images. Extrasolar planets, also known as exoplanets, are circling other stars, and astronomers wanted to know how many of them have environments favorable to the development of life. Kepler was in orbit for a total of 9 years, during which time it observed 530,536 stars and confirmed 2,262 new exoplanets. We have never seen anything like these exoplanets in our solar system. Most of them orbit extremely close to Earth despite being significantly larger than our planet. Some of these planets have sides that are hot enough to melt iron, and entire hemispheres are covered in oceans of liquid molten rock, on account of their stars completing one revolution every few days. Jupiter-sized exoplanets orbiting more than one star are also known to exist. Kepler's legacy is the discovery of Earth-sized worlds orbiting at a safe distance from their host stars within what is known as the Kepler disk. If you were standing on the surface of one of these planets, you would see a binary sunset. The Goldilocks zone, also called the habitable zone, is the temperature sweet spot where liquid water can condense on objects but not freeze solid. The presence of water is essential, as it is the building block of life as we know it, and being in this zone is no guarantee that life will exist. K218b is one Kepler-discovered exoplanet that has recently piqued the interest of scientists. Two separate research groups made their September 2019 discoveries public. Evidence of water vapor in the Earth's atmosphere planet is a major find in the quest to identify extrasolar planets with the potential to support human life. In addition to being the first watery exoplanet discovered by Kepler, K218b also lies within the habitable zone of its star. After its initial discovery by Kepler in 2015, other telescopes like the Spitzer and Hubble Space Telescopes have been used to analyze the planet's composition. When searching for exoplanets, Kepler relied heavily on what is now called the transit method. When a planet crosses in front of a star, it causes a temporary reduction in the star's brightness. And that's how we know for sure that a planet exists there. Information about the planet's mass and orbit can be gleaned from the magnitude and duration of the dimming. However, it is difficult to detect the transit of an extrasolar planet. For instance, because Earth's diameter is only 1/109 of the Sun's, the transit of Earth would obscure the Sun's light by only 0.02% to an observer on the outside of the solar system. 008 Kepler's cameras had to be extremely sensitive for this method of detecting a change in brightness to work. When NASA announced the discovery of Kepler 186f in 2014, it sparked the imaginations of space nerds everywhere as the first potentially habitable exoplanet found by Kepler. A recent study suggests the exoplanet that is 500 light-years away from Earth may share our climatic and seasonal patterns. Recent analysis of Kepler 186f's spin and axial tilt by researchers at Georgia Tech University indicates that the planet's tilt is stable, much like Earth's. Kepler discoveries that were initially discarded as unlikely candidates for exoplanets of Earth's size are being rediscovered in recent years. It is taking time, but these false positives are finally being reanalyzed with data from other telescopes. Kepler 1649c is one such planet, discovered in the middle of the year 2020 by comparing old and new Kepler data. Another exoplanet with ideal conditions for life has been confirmed by data from the Transiting Exoplanet Survey Satellite, or TESS. Kepler 1649c, located 300 light-years from Earth, has dimensions and an estimated temperature very close to those of Earth. Only the first of many worlds has been revealed. Because it receives the same amount of light from its host star that Earth does from the Sun, the exoplanet's temperature may also be similar to that of Earth. However, before we get too excited about Kepler 1649c, We should remember that only 16 of the 2662 exoplanets identified by Kepler lie within the Goldilocks zone of their host stars, and only one of these 16 is an Earth-sized planet. Only one hemisphere of a tidally locked planet faces its parent star, which is bad for supporting life. Some are more similar to a dwarf Neptune than a giant Earth, and planets that are thought to be like Neptune should have a thick hydrogen shell surrounding any surface water and a rock and iron core. If the hydrogen shell is too thick, the water below would be too hot and under too much pressure to support life. Planets orbiting red dwarf stars may be subjected to more harmful ultraviolet radiation than Earth is because, despite being cooler, red dwarf stars tend to be more active than Sun-like stars. As a result, surface temperatures can swing from below freezing in Antarctica to above boiling in the hottest deserts on Earth, with no two places on the planet experiencing the same average temperature. Regrettably, our lack of technological prowess prevents us from investigating. Don't lose hope just yet if you don't know the composition and atmospheres of these alien worlds and the complete answers to all these questions. Astronomers now believe that 1 in 5 Sun-like stars harbor Earth-sized planets with an atmosphere and surface temperatures suitable for life, based on a statistical analysis of all the Kepler observations. About 20% of the stars in our galaxy are Sun-like, so there are likely billions of Earth-like planets just in our Milky Way. Not only did Kepler zero in on its searching for planets with the potential to support human life, in fact, the vast majority of its discoveries were inhospitable but fascinating alien worlds, such as hot Jupiters, or gas giant planets, made mostly of gases like hydrogen and helium with a relatively small rocky core. Kepler's data is rife with examples of planets in extremely close orbits to their parent stars. Koi 5ab is an interesting case of a gas giant. Koi 5ab was first identified as a possible planet by astronomers in 2009. This enigmatic alien world was Kepler's second planet discovery. A decade ago, it was overlooked for two reasons. First, Kepler produced an overwhelming amount of data, and second, astronomers noticed that the primary Koi 5a star had another companion star, complicating analysis. The Koi 5 system was much more intricate than scientists originally thought. The presence of 3 stars in the Koi 5 system was confirmed in 2014. And it was still unclear whether or not Koi 5ab was a habitable world, actually existed, or if the 2009 signal was generated by one of the companion stars. But thanks to additional data from the TESS satellite, scientists have confirmed the existence of Koi 5ab planetary bodies on stable orbits in a multi-star system. The discovery of Koi 5ab is extremely unusual and will likely contribute significantly to our knowledge of planetary formation. Kepler also discovered something called super-Earths, which are larger than Earth but less massive than ice giants like Neptune and Uranus, and are sometimes composed entirely of gas. Some of these planets, called Chthonian planets, are likely the remnants of evaporated hot Jupiters. Others, called Trojan planets, are planets of varying sizes found in strange locations and sometimes even as companions to larger planets. However, none of these planets have been positively identified as of yet. After running out of fuel on October 30, 2018, Kepler was officially decommissioned. With a goodnight command, the telescope was turned off. Kepler's retirement the following month coincided with the 338th anniversary of Johann Kepler's death, for whom it is named. Kepler's incredible discoveries indicate that in the not-too-distant future, astronomers will use new and advanced telescopes on the ground and in space to better understand Kepler's numerous discoveries, despite the fact that Kepler is no longer operational. Already in 2021, we plan to launch one such telescope into orbit. The James Webb Telescope will examine some of these Keplers in exquisite detail. Thanks for